Thank you, Marcy, and thank you everyone for joining us. We realize that this is a busy time of year with all the holidays going on, and we appreciate that you've joined us today to learn more about nail-laminated timber, glue-laminated timber, and cross-laminated timber. As Marcy mentioned, Lori will also be co-presenting with me, and we're going to do a little bit of a different format where I'll be presenting, then she'll be presenting, and then I'll round up the webinar at the end. This presentation is copyrighted by the American Wood Council. If you'd like to use any portion of the presentation, please contact us. And for those of you that were able to download the handout, our PDF, and actually if you look at your menu or your sidebar of the GoTo webinar, there's a section that has handouts that has a link to the actual handout. This is something new that we've discovered with GoTo webinar. So you can click on that link and quickly download the PDF. But I've included a description as well as the learning objectives. Let me get that. Learning objectives for your reference. Those were provided for you when you registered for the webinar. And what we'd like to do, well, let me go back to the learning objectives. We're going to talk about identifying code acceptance of the three products, nail-laminated timber, glue-laminated timber, and cross-laminated timber. Then we'll look at some number of technological advances with these three systems. And then also we'll look at some building systems that have new types of mass timber products, and to improve your design knowledge on these systems. And then we'll become acquainted with fire resistance characteristics of these three, and then look at how some provisions within the NDS can assist with calculating the fire resistance. So before we get into our presentation, we always like to understand what the makeup of the audience is today. So Marcy?
All right, let's see. The first poll is, what is your profession? Go ahead and select one: architect, engineer, code official, building designer, or other. And as usual, I give you about 30 to 45 seconds, or 80% voted. So, and this, of course, is the easiest question to answer. All right, I've got about 80% voted, so let's go ahead and close, and then I'll share. We've got about 69% engineers, 13% code officials, 8% architects, 8% other, and just about 2% building designers. So welcome, everybody.
Great, thank you, Marcy. So could you repeat that again? Sorry.
Oh, sure, no problem. 69% engineers, 13% code officials, 8% architects, and 8% other, and then 2% building designers.
Great. So we have a large concentration of engineers, which is what we expected, and then code officials, and then architects. Great. We have a good mix in the audience. So hopefully you'll be able to obtain some valuable information related to these wood products. Now, to give you an idea of how we're going to work our way through the presentation, first we'll talk about an overview of building code allowances and an overview a little bit about wood construction. Then we'll get into nail-laminated timber, which has actually been around for quite a long time. And then Lori will pick up with glue-laminated timber and cross-laminated timber, and then I'll follow up with the fire portion of the presentation. And so, first off, overview and code building or building code allowances. Now, a lot of us that are in the building industry, when we think of wood construction, we probably think of the traditional stick frame construction, or which is a predominant sector is the mid-rise construction, but we have other sectors where wood construction is used, and many of us call it stick frame construction, where we're using 2x members or engineered wood products to construct a building. We also may be very familiar with heavy timber construction. This is an example of a project up in my old alma mater, Cal Poly San Luis Obispo. It's the Simpson Strong Tie Demo Lab. which is a one-story with a mezzanine in it. And traditionally, it used heavy timber construction, but some people may have thought that this could have been done in steel, but they chose to use timber, heavy timber, because of the aesthetic appeal and the environmental benefits of using wood, as well as the visual benefits of using wood. This used for the lateral system braced frames, heavy timber brace frames, which for those of you that are familiar with Uniform Building Code was a prescriptive method of providing lateral resisting systems, and then for some reason when it transferred to the IBC it was no longer a prescriptive method. And so this project was actually under the IBC, I believe it was 2006, where they had peer review and it was approved as a method of providing lateral resistance under the IBC. And we also have heavy timber construction utilized in this Raleigh-Durham airport in the roof system, where they use curved glue-laminated timbers. And you can see tension rods in the bottom with a sort of a post up on the top to connect it as a system, something that's very aesthetically pleasing. And also, we have bridges that are successfully used throughout the nation and the world using heavy timber construction, in this case the glue-laminated timber. This one is a pedestrian bridge spanning 105 feet that was successfully executed, and the key to obviously exterior uses of glue-laminated timber or any wood products is in the detailing and the protection of the specification of the wood members that are being used, and Lori will get into that more later in the presentation. Another example other than heavy timber construction with using glue-laminated timber is nail-laminated timber. As I mentioned previously, this has been used or in the code for quite some time and becoming more and more popular. This is a project in Culver City, California, high seismic zone, that utilized it under Type 5 construction. And as you can see, it's laminated 2x members that are connected together and designed per principles of mechanics, and we'll get more into this later. But they were able to have this all exposed so that the occupants can view it and get that effect of the wood construction. This is a project in Seattle, Washington called the Bullitt Center. It's touted as being the greenest building in the world when it was built, and used heavy timber construction as well as nail-laminated timber construction and having it all exposed. And then now we have an example of a cross-laminated timber. When this building was built back in 2009 in London, it was the tallest cross-laminated timber building in the world at that time, where they constructed it entirely of cross-laminated construction except for the first floor, which was concrete. So it's similar to a podium type project, but using one level of concrete construction and then 8 levels of cross-laminated timber with the floors, the walls, and the roof and the ceilings all out of cross-laminated timber, solid wood. So what's driving this effort for using wood construction? And this is very timely considering what was going on in Paris past couple weeks related to climate change and the discussions with representatives from countries around the world discussing climate and the importance of understanding carbon and how that plays into the role of climate change. Related to forests and the use of wood products, this is an example of the cycle of what we would see out in the world with forests. We have the forest, and as we know, when trees grow, they take carbon dioxide from the environment and store it within its body, and then we release oxygen. And once that in the forest, I'm having a little issue technically, what we could see is sometimes if we have a forest that's not maintained or densely populated forest that can lead to some health issues with the trees. We can also see sometimes insect infestation that weakens the trees, and then those trees can be prone to wildfires. And then what happens is when there are wildfires, or when they're no longer efficiently storing carbon dioxide, that carbon dioxide can be released out in the atmosphere. However, if we have a sustainable forest where we're constantly regenerating forest, or removing some of the trees from that forest and then making them into wood products or other types of products, we can store that carbon that was created from the tree for long-term storage. So they're carbon sinks. And this is, or we can also utilize some of that wood for bioenergy. And this is one of the main reasons that we're seeing more and more use of wood products throughout the world. Now, as an example, here's a wood building, and it's, for example, it could be your home. Many of us live in wood homes, and if we had a wood home that's 2,400 square feet, that is estimated as 32 cubic meters of structural wood, and which equates to 29 metric tons of carbon dioxide, because wood is roughly 50% carbon dioxide. So for long-term storage, that is storing as much as 5.7 passengers' annual emissions, carbon dioxide emissions from a car. Reason. And I mentioned this Strad House project in UK that utilizes cross-laminated timber, 9 stories, one level of cross-laminated timber, and that was the main driver for them using cross-laminated timber, because of the carbon storing capabilities of the cross-laminated timber. The next one, that was the next tallest building, is here showing the Forte project. It's a 10-story project, similar to the UK project in that it has 1 level of concrete and 9 levels of cross-laminated timber, stored several metric tons of carbon dioxide in the structure. It was completed in December 2012, and the erection of the project was very quick. It went up very fast. So some examples of what we'll be talking about later in the presentation. Now that we know why some countries are really embracing the use of wood products, now we'll see how this is applicable to the United States and to the 2015 IBC, which is the next code. Many of the states throughout the nation are adopting the IBC 2015. Well, first we'll talk about glue-laminated timber and how is that allowed. This project happens to be in Tacoma, Washington. It was actually, I believe, a type 2 construction, but they were able to use glue-laminated timber as part of the roof. Now, some of you may not be familiar with different types of construction, and in Chapter 6 is where the types of construction are defined. From type 1 to type 5. Type 1 and type 2 are typically non-combustible inside and out, but there are applications where wood can be used. And then type 3 is a little bit of both. You have non-combustible exterior, and then interior is any acceptable material in the code, which includes wood, obviously. But it also allows the use in the non-combustible exterior walls. It allows the use of fire retardant treated wood. And then we have type 4 and type 5. Type 4 is heavy timber construction, and type 5 is permits, again, any material that's permitted in the code, which also includes wood. But for glue-laminated timber, the topic we're talking about, they were allowed to use glue-laminated timber in this construction for the roof construction. And we'll look at a table where it actually specifies the allowance of heavy timber construction. The other application is nail-laminated timber, which is allowed, and it's allowed under type 3 construction or type 4 and type 5 construction. And then I mentioned about the application of roofs, glue-laminated timber in the roof system. This is from Chapter 6 of the IBC, which is a table 601 that provides provisions for fire resistance rating requirements for building elements. Now this is just based on the type of construction. There are other fire resistance requirements in Chapter 7, I believe it is, related to other fire resistance requirements. So just based on the type of construction. If we look at this, we would see roof construction here on the last row that gives you your fire resistance requirements. Now we look at, there are some footnotes that allow, for example, for type 1 construction, it allows heavy timber may be used where 1 hour or less of fire resistance rating is required. So for type 1B, type 2C, type 2A and B, it allows heavy timber construction. And also there's a footnote B, so for type 1A, footnote B allows for all occupancies except for these occupancies listed here. It allows for, if your roof is 20 feet or more above the floor below, it allows fire retardant treated wood to be used. So in type 1A, it allows for the roof construction fire retardant treated wood. Just some caveats that, or some exceptions to the non-combustible construction. Now for cross-laminated timber, this is something that many of you have probably heard of, but it's new to in the IBC 2015. In the 2012 code, it was not included as a method of or a material that can be used or a product that can be used for construction, but now it is in the 2015 IBC, which is stated here. It's in Chapter 23. It provides a definition, and also what is key here is the manufacturing standard for cross-laminated timber, which is ANSI APA PRG 320 2011, which provides a standardized method of manufacturing the cross-laminated product, and we'll get more on that later on in the presentation. Now, to introduce this or to have it adopted within the 2015 IBC, there were testing that's provided, and one of the concerns may have been, well, is when we're talking about fire, when we're talking about adopting something into the code, is related to fire. And a couple of fire tests that are shown here. You can link on this and download these fire tests. The most recent one related to the 2015 IBC is a test that was done by the American Wood Council that showed that there is some fire resistance. There is fire resistance up to more than 3 hours of fire resistance for a cross-laminated timber assembly. This actually was one that had a 5-ply cross-laminated timber, manufactured per the APA PRG 320, and this test was an ASTM E119 fire endurance test, and it has 5 layers of cross-laminated timber and then 5/8 type X drywall on each side, and we sought to have 2 hours of fire resistance rating, but it resulted in 3 hours and 6 minutes 3 hours and 6 minutes of fire resistance rating. And as you can see, the only reason why the test was stopped was because of the breach of between the drywall and the cross-laminated timber. But the cross-laminated timber still had a lot of fire resistance in its wood product. It didn't fail structurally under the fire test. So the sections that were adopted for heavy timber construction in the 2015 that specifically states that cross-laminated timber may be used under the heavy timber application, and it can be used in the exterior walls, and this is important that the 3 applications where cross-laminated can be used in the exterior walls is where we have 2-hour fire resistance rating or less, and that the exterior surface is protected with fire retardant treated sheathing or 15-30 second, which is or not less than, so it's sheathing of not less than 15-32 inch thickness. a fire retardant treated sheathing. And then we also have, or you can apply 1/2-inch thick gypsum board or of some non-combustible materials. So those are the 3 requirements if using cross-laminated timber in the exterior wall application. It also can be used for floors, provided it's a nominal minimum thickness of not less than 4 inches, and it also can be used in roofs where we have a minimum thickness of 3 inches in that application. And this is similar to other wood such as glue-laminated timber where there are minimum thickness requirements in the heavy timber construction. And then for walls and partitions, it can be used on the interior walls and partitions provided it's 4 inches minimum thickness. And then exterior, for the exterior wall applications, I'd mentioned the fire retardant treated wood or having drywall. But the minimum thickness of the cross-laminated timber needs to be no less than 6 inches. So when we're talking about cross-laminated timber, it can be used in heavy timber construction. And under heavy timber construction, the one thing that many people may or may not be aware of is that there can be no concealed spaces. That's one of the requirements of heavy timber construction. So it could be used in the floors, the walls, and the roof. The entire building can be made out of cross-laminated timber under heavy timber construction. And it can also be used under Type 5 construction, which allows any permissible material within the code, that being cross-laminated timber. And then also, these are kind of out of order, sorry about that. Type 3 construction, which allows fire retardant treated wood out on the exterior of the building, and then any material in the for the floor applications or the roof applications. So cross-laminated timber can be used in Type 3 construction. Now, so summing it up, under the 2015 IBC, it can be used for most occupancies in Type 5, Type 4, and Type 3 construction. So now, Marcy, I think we have a...
We absolutely do. So the 2015 IBC allows cross-laminated timber to be used in which of the following applications? Is that Type 3, 4, and 5 construction, roofs, floors, or all of the above?
And as a reminder, these quizzes, your certificate of completion is not dependent on you answering the question correctly.
All right, we're almost at 80%. All right, I'm going to go ahead and close the poll. And we're split between all of the above and A, Type 3, 4, and 5 construction. So 87% say all of the above, 13% say Type 3, 4, and 5 construction. So Michelle, what is the real answer?
The correct answer is all of the above. And that is true. Cross-laminated timber can be used in all of the above. And so we'll go on. Great answers, and actually they're all right because they're all the answers, but the more correct answer is all of the above. Now, getting into an area that engineers may not get into when looking at the design of the building, this has to do with determining the size, the allowable size of the building under the code. This is from the 2015 IBC, and this table probably looks a little different than what we've used in the past building codes because they've changed the overall format or method on how you can obtain the size of your buildings. One thing to note is the end result is the same as it was in previous codes. It's just how you get to the end result that is changed. And I should note at this point that some of you may be familiar with our Code Conforming Wood Design publication. We've updated our 2012 to the 2015 2015 version that has a lot of helpful tables related to determining the size of the building, and that's available for free on our website. But getting into this table 504.4, this provides a table for the allowable number of stories above grade depending on the occupancy and the type of construction. And you'll see, for example, for a business occupancy and type 3 or type 4 or type 5 construction with this is NS is no sprinklers and S is sprinklers. For business occupancy, you can go up to 5 stories in type 3A construction. And then you gain a story going up to 6 stories with type 3 construction. And then another new table, which gives your baseline allowable square footage, depending on whether or not you have sprinklers. For this, there are no sprinklers, and then 1 story with sprinklers, and then multi-story with sprinklers. So again, if you have a business occupancy, your type 3A construction with no sprinklers, you're at 28,500 square feet. However, if you're 1 level of type B construction, of business occupancy, and S1, that's 1 level and sprinklers, you can go all the way up to 114,000 square feet under type 3 construction. And then for cross-laminated timber, obviously that would be under type 3 or type 4. Type 4, you can get as much as 144,000 square feet using cross-laminated timber in a business occupancy application. Also, we can do an example here for R2 occupancy. If we're in an R2 occupancy, we have no sprinklers, or we have sprinklers with 13R sprinklers, which is a less of a robust sprinkler than just pure NFPA 13 sprinklers. But if we're there with no sprinklers or NFPA 13R sprinklers, and we're in, say, type 3 construction, we're allowed to go to 24,000 square feet. Which is shown here. Now what I didn't show is the table that shows the height. There's a separate table that gives you the allowable height, and it's table 504.3, that you can go up to 60 feet, and then if you have NFPA 13, not 13R, you can go up to 85 feet. Now for those of you that are in California, it's a little bit different. California amends the code related to sprinklers and the height requirements, so you have to look at that, the CBC specifically for those requirements. But again, and if you're in heavy timber construction, you're at 20,000 square feet, 20,500 square feet. So quite handy tables. Now, what are the governing codes related to cross-laminated timber or any of the wood products that we're talking about? We have the IBC, and that references the 2015 NDS, which is actually available on our website for free. And some changes that have occurred to the NDS related to the overall format is, and now we're getting into the structural requirements of NDS, of designing with these products. The overall format that has changed from the 2012 to the 2015 is, in order to group the wood products together, we added a Chapter 10 dedicated to cross-laminated timber. And then the subsequent chapters were actually renumbered all the way up to 11 through 14 that covers the connections. And then Chapter 14, which was just a 1-paragraph statement that referenced the wind and seismic provision, was moved up into Chapter 1. And then, Chapter 15 and 16 remain the same designation. Under the NDS, we have some recorded webinars actually on the 2015 NDS if you're interested, but given the products that we're talking about today, we would have the nail-laminated timber that would be under the Chapter 4, sawn lumber. Then we have the glue-laminated, structural glue-laminated timber in Chapter 5, and then cross-laminated timber would be under Chapter 10. So starting off with nail-laminated timber, we can see here a picture of a roof application of nail-laminated timber. And what it is it's 2x members that are connected together, all aligned, similar to decking, but you would have it vertical instead of flat. And they're all connected together with a mechanical application, in this case, nail-laminated application. I didn't show the nails throughout all of the members, but that's an animation about what it is. And it's also covered in the IBC under section 2304.8.3, all the way down, covered under the mechanically laminated decking. And it gives you some provisions related to the nailing, minimum nailing requirements, the layout patterns, and how they're supposed to be supported, all covered under the nail laminated or mechanically laminated decking. And there are some minimum size requirements as well. Now, this gives you an example of what nail-laminated timber is. They can be used in a very creative manner where you're using the 2x's all connected together and creating an architectural design within the nail-laminated timber. This particular application used the tension wires on the bottom and then an architectural application of posting up to create a system to span the distance for this nail-laminated timber roof system. Here's another example where instead of having a curved section property, this actually has just a regular rectangular section property. This is a project up in Surrey, British Columbia, and using a prefabricated process where they nailed all the members together in the shop and created a system that they can prefabricate and create a system to have produce a ease of construction and fast construction. So it's all prefabricated off-site, bring it into the job site and connect it easily together. Okay, and now I'm going to hand it off to Lori. Let's see. Are we going to Lori?
Can you see my screen?
Yeah.
Oh. All right, great. And I'm guessing you can hear me too. So, all right, well, thank you guys for sticking with us. You'll have a little time with me. I guess today's webinar is kind of like a sandwich, and I'm in the middle. So we'll start off talking about, I'll start off rather, Michelle's been with you guys, talking about glued laminated timber, or glue-lam for short, and then I'll talk a little more about cross-laminated timber, and then we'll give it back to Michelle for the fiery conclusion. So what is glue-lam? As I said, that is a shorthand term for glued laminated timber, which is a structural composite made with lumber and adhesives. The most common species you'll probably see are going to be southern pine and Douglas fir, and you can see that there's a little note down here on the bottom right that denotes that the layers, the laminations, the individual pieces of wood that make up the laminations will vary in thickness with species, and I have that on another slide as well. But I just wanted you guys to be aware that you will want to confirm sizes with your supplier. So the way glue-lam works is that the laminations of wood are bonded together with an adhesive that is manufactured according to very rigorous standards, and the grain of the wood runs parallel to the length of the beam. So that means that the strong axis of the beam is oriented all in one direction. So as I said, individual lams or laminations, lams we sometimes call them, are typically 1 3/8 thickness for southern pine and 1.5 inches for your western species like Douglas fir. So again, check with your supplier to see what kind of materials they have in stock for your region, because it will vary regionally. The widths typically range, you can get them anywhere from down to about 3 1/8, 3.5 inches wide, up to 10 3/4 inch in widths. Some of the smaller sizes will probably be readily available. Larger sizes might have some lead time. And the nice thing about Glulam is that you can have it custom made in any size you want, really. As long as it can be transported, I guess. One of the nice things about the Glulam is that it takes what is labeled in this picture here as a natural characteristic. Some might call it a knot or a strength-reducing characteristic, possibly. And it takes those natural characteristics and it spreads them out so that through the cross-section your defects are spaced out and they're not all concentrated in one area. So this makes for a more efficient cross-sectional design. You can also see, the lumber laminations are called out in this picture, as well as the glue lines. They're pretty straightforward. One other thing that's called out in this illustration is the end joint. And if you look closely there, you can see that this is an example of a piece of finger-jointed lumber. And that's fairly typical. So they'll use finger-jointed lumber to use the smaller sections to make a much larger overall member. So the standards there for Glulam that exist are for not only the product qualification and the quality assurance, but it also has requirements for third-party inspections as well as the grade mark requirements. So the standard for Glulam, as you can see here, is ANSI A190.1, and this is the 2012 version. So it serves, the two main purposes that it serves, as I said, were establishing national requirements for not only the production but also the inspection and testing and certification of structural Glulam. And it also provides material suppliers, producers, distributors, and users with a basis for a common understanding of the characteristics of the product. So the manufacturers know what they need to make and what the requirements for the product are, and the people specifying it understand the strength characteristics of the product. As I mentioned, Douglas fir and southern pine are some of your more common species that you'll see Glulam manufactured in. Other softwoods, such as the SPF and hem fir species classes, are available as well. Another thing that you'll see available are naturally durable softwoods, such as an Alaska yellow cedar or a Port Orford cedar. Those are used in more so outdoor or instances where you need the natural durability of the cedar. And you can also have them made with hardwoods. And there's also mixed species layups that are available, where you have varying species throughout the member. With Glulam manufacturing, the way the laminations are organized or oriented is referred to as the layup. And in this slide, we show two types of layups that are fairly common. The left one would be an unbalanced layup. So that's for a simple span, floor beam or something along those lines, where you're going to have tension at the bottom, compression at the top. So you'll use the lowest grade material, the number 3, in the middle, closest to the neutral axis, where the stresses are lower. And as you get further and further away from that neutral axis, the grade of that material will get better to accommodate the higher stresses at those extreme top and bottom fibers. Now, if you have a continuous span or a cantilevered span where you see tension not just in the bottom but in the top as well, you'll use what's called a balanced layup. So in this one on the right, you can see that we have a tension lamination, or a TL, which is a high-quality piece of lumber, or could also possibly even be an LVL. Used as a tension lamination, and then again the number 3, weaker material closest to the neutral axis. So here's an example of a simple span glue lam. Pretty straightforward, right? It's just a girder with joists framing into it. And this one here, you can see with the post in the middle of the picture, this would be a continuous span, so you would need to use a balanced layup in this situation. Now, when you're specifying an unbalanced layup, they do mark which side is the top, so that's something that you'll want to be aware of, especially if you're doing on-site inspections. You know, it's never good when you're standing underneath a glue lam beam and you look up and see the word top on the bottom of the beam looking down at you. So that you do want to be aware that for unbalanced beams, that's especially important to have it oriented in the correct direction. There is another layup that is sometimes used, and that's a single grade layup. And that's commonly used more for instances where you have the stress distribution is axial, so you have the same stress throughout the cross section. So this is common in glue lam columns, also glue lam truss cords, and you can see we've got some pictures here. This is a pretty large beam that has glue lam truss cords and webs, and we've got some glue lam columns in this picture on the bottom right as well. So these would be instances where you would use a single species layup and a single grade. Now, beyond the layups, there's also the appearance of the glue lam that you would need to specify. And there are 4 main types of appearance classifications that you'll want to be aware of. So framing is the first, and that's generally used in places like headers where it's going to be concealed inside of a wall. Typically it's in 3.5 and 5.5 inch widths for the framing class. And you'll see that the framing has a little L next to it that's denoted, and industrial also has that little L. That means that you can get these members available with LVL tension laminations. So that would be only in the framing and the industrial classifications. Industrial classifications are somewhat similar to the framing appearance classification in that it's used in applications where the appearance is not important, or it could be used in an enclosed area, such as a header that's inside of a wall. If you're going to leave the member exposed and you're concerned with the appearance of it, then you would want to specify an architectural grade. And if you wanted to go with something that is some sort of super premium product, you can do a custom order for a premium appearance grade. But again, those will need to be premium again, a custom order that may not be available locally, so you'll need to coordinate with your supplier. Now, one thing about the appearance classification is that does not have any effect on the design values of the glue lam. So, you know, given a stress class, an architectural glue lam beam and a framing glue lam beam from the same stress class will have the same structural design values. They just would probably look a little bit different. So the glue lams, as I mentioned, are required to bear a grade stamp. So here's an example of one that you would see from an APA member that was certified. The B that you see on the, let me see if I can get my little pen to work here. So the B, oh, here we go, felt tip pen. All right. So this B here indicates the use class. So B for structural use for a simple span bending member. You could also see the letter C for a compression member, or T for a tension member, or a CB, which would indicate continuous or cantilevered span bending member. The IND that's next to the B, that's the appearance class. So that's what we talked about with the industrial or architectural premium framing. That would be denoted there. The EWS indicates that it's using the EWS laminating specification, which is the laminating specification that is called out for this. And the 24F here indicates the allowable bending stress. So for a 24F, that would have an allowable bending stress of 2400 psi. The 1.8 is the modulus of elasticity, and so for that it's 1.8 times 10 to the 6th psi. And the E next to the 1.8 here, this E, is going to indicate mechanically graded lumber. If there was a V there, that would indicate visually graded lumber. The DF is the species, so that's Douglas fir. You can also see SP for southern pine. And then the mill number at the bottom is the mill ID for where it was produced, and the ANSI AITC A190 at the bottom is the production standard. So there's a lot of information contained in one little grade stamp. So since we've got your head spinning with that, now's a good time to step back and do a little poll. So Marcy, I will turn it over to you.
Perfect. Okay. So we have the glued laminated timber layups can be one of the following: balanced, unbalanced, single grade, or all of the above. All right. Wow, there's quite the unanimous answer. Okay, I'm going to go ahead and close the poll and sharing. All right, the majority say all of the above. And the correct answer, Lori, is did we lose you, Lori?
Sorry. Can you guys see
Okay,
my screen? I had muted myself to get a drink and then forgot to unmute. So the correct answer is all of the above. So can you guys see that? Make sure. All right, cool. So, and that was what we talked about. The balanced is for continuous spans, unbalanced is for simple spans, and the single grade would be more common for something like a column. As Michelle mentioned, there are product chapters in the NDS that deal with the different products, and Glulam, structural glued laminated timber, has its own chapter. That's going to give you the necessary design requirements for structural design. It's going to provide you with adjustment factors, and it also will provide you with general information about designing with Glulam. As far as design values, Glulam is nice in that you can see that we have reference design values for it as part of our supplement. So Glulam, since it's a standardized product and not necessarily considered a proprietary product like other engineered wood products are, we are able to have stress classes that are available in Table 5A, which you can use to design according with. So you'll see that these design values look a little bit different than just your Table 4 with solid sawn lumber. So you'll see that there's, bending in the positive and negative directions and bending about both the strong and the weak axis. So it gives you a little more information which you'll need to design with Glulam. Glulam can be preservative treated. It's usually treated in a pressure cylinder, right? So they load the Glulam into the pressure cylinder, close the door, they pull a vacuum on it, and it forces the preservative chemicals into the wood cells. As with many species, some species of Glulam will require incising for difficult to treat species. So with solid sawn lumber, we have the C sub I incising factor. With Glulam, we don't have to take that incising into account because it's already taken into account in the manufacturing process. So any strength reductions to the overall member are accounted for, and you don't have to take any additional reductions due to incising based on the stress class that your beam is labeled with. So as I mentioned, incising for hard-to-treat species, as I always like to point out with treated lumber, some of the newer treatments have been shown to corrode untreated fasteners, so you'll want to use either a hot-dipped galvanized or a stainless steel connector if you're using treated lumber. If you are making cuts in the field to treated lumber, you will need to treat those exposed faces, such as you'll want to use something like a copper naphthenate per the IBC and IRC requirements. And as I mentioned, the approved treatments and processes don't affect the structural properties. Those are all taken into account before the beam is stamped with its final grade stamp. Some of the naturally durable species that you might see Glulam manufactured with are going to include the Port Orford cedar, Alaska yellow cedar, Western red cedar, and California redwood. So, and those are the typical typical stress classes associated with those species. Now, the IBC does have a definition for a naturally durable species, and they state that 90% or more of the width of each side has to be heartwood with occasional sapwood permitted. And that, I don't know, I guess that 10% requirement is where the occasional comes from. And these are probably the most common species that you would find Glulam available in terms of naturally durable species. So one of the benefits to using a naturally durable Glulam over a treated Glulam was realized by the folks out in Santa Monica, California. They had a reservoir that they wanted to cover, and they didn't want to use any sort of treated lumber or anything with any sort of chemicals in it, because obviously this is drinking water and you don't want any sort of contamination. So they went with an Alaska yellow cedar for this reservoir cover, and it was pretty sizable, and it's all Glulam and it's holding up great as far as I know. So next we'll talk about cross-laminated timber. Michelle already touched on it a little bit. It is kind of similar to Glulam in that you're taking nominal 2x members and placing them in layers and gluing those layers together. But with Glulam, where the strong axis is all oriented in one direction along the length of the member, for cross-laminated timber, every other layer has its strong axis orthogonal to the adjacent layer. So that means that each layer has a strong axis that's 90 degrees from the one next to it. And you can get cross-laminated timber manufactured in any plethora of different sizes. It can be anywhere from 4 to about 18 inches thick, up to 11 feet wide by 65 feet in length. So the manufacturer will tell you what kind of sizes that they are able to produce. But there is a lot you can do with this stuff. So you can see it's glued under a pressure. It's glued, and then a pressure is applied to it. And the shrinkage through the thickness of the panels minimized because they do kill and dry the boards before they glue them and laminate them. So that provides some dimensional stability. In terms of cutting these things, CNC is a wonderful tool and allows you to do some really neat things with these panels. So you can have all of your window openings, your door openings, electrical chases, slots for connections. All these can be cut in prior to the panels being shipped from the manufacturer. So you can have everything cut out as you need it, and which will reduce your on-site construction time. So you can see what the panels look like when they're ready to ship. And the typical construction details for CLT, usually you can use a spline or a lap joint to connect the panel-to-panel joints, and then, but got ahead of myself. So you can use splines. One thing you will want to be aware of is that the manufacturing process doesn't apply any adhesive between the narrow face of the laminations, and there's not really any test data that's been performed on the application of load in that direction. So if you are using these in a lintel or header in a bearing wall, you will need to install additional framing. So in bearing wall applications, though, so these can be glue lam, they can be LVL. You can use any type of header you would want. The typical panel connectors that are for floor-to-wall connections are not unlike what we're used to seeing for wood connections. Lots of lag screws, angle brackets for floor-to-wall connections. These screws are generally self-tapping. They go in fairly easily as long as you can put them in straight. And it really allows you to put these buildings up really quickly. So you can see here the panels being connected on a project. It doesn't require any special tools beyond a screw gun, so you don't have to have any additional tradesmen on the site. Now, for the first time ever in 2015, cross-laminated timber has its own chapter in the NDS. It is in Chapter 10. And as you can see in Chapter 10, we call out a manufacturing standard, which is ANSI APA PRG 320. So the thing about cross-laminated timber is that while the manufacturing process is standardized, the design values are not. So you will need to get the design values either from the manufacturer or from they'll be listed in the standard as well. But the design values can vary from manufacturer to manufacturer. Another thing you'll want to be aware of is that a lot of the panels being produced in Europe, CLT has been around in Europe for quite some time. They are not produced in accordance with ANSI APA PRG 320. So you will want to ensure that if you are sourcing the panels from Europe, that they were produced in accordance with this specification. So the standard sizes that you'll see, as I mentioned, are going to be laminations between 5/8 of an inch to 2-inch thick, and this is all in PRG 320. The maximum thickness of the panels would be 20 inches, and the laminations need to be fastened with adhesives. So you can't use nails or screws to fasten the layers together. It has to be laminated with glue. And as you can see in this illustration here, you can have 1, 2, 3, or even 4 transverse layers. You can have multiple or single surface layers. So there's a variety of different orientations of the product, and they'll give you different results in terms of the structural properties. As I mentioned, so those reference design values have to come from the manufacturer's literature or an ESR. So the information is available. As I said, there is minimum required characteristic test values for these different CLT grades, and this is in PRG 320. And these are going to be in section 8.5 of the standard. Now, when you go to the Appendix 1, this is going to provide allowable design properties for the grades of CLT. This represents the use, or represents the production that's going to be intended for use by CLT manufacturers in North America, and it is based on the layups that are shown. So you can see the CLT grades that are shown on the left in the very first column, and they are laid out. They are specified what each layup means. So it talks about the species, the stress rating, and the grade of each panel and what goes into it. And when you go into the standard, you'll see this as well. These are going to be the geometric properties that you'll need. And you can see that these geometric properties are referenced in the NDS table. So those geometric properties are coming from the manufacturer as well, or the standard. So that makes this a little bit different than the glue-lam table. This is more akin to like the I-joist table in the NDS because you have to have those geometric properties available to you. Whereas with the NDS, the design values are independent, mostly independent of the geometric properties of the member. Chapter 12 was updated in the 2015 NDS, and that was updated to include CLT connections. So there are different, There are different assumptions made when designing connectors with CLT. So when you're designing a connection for a lateral load, and for those of you that were on our connections webinar last month, you'll probably remember this. When designing a lateral connection, you generally assume a uniform cross-section providing uniform bearing throughout the length of the fastener. But with CLT and the changing grain throughout the cross-section of the panel, you are not now having the uniform bearing along the length of the fastener. So we had to take into account that and a few other differences that are inherent with CLT versus solid sawn lumber or even glue-lam. One other issue that has been coming up with CLT that we have been working on trying to solve is the seismic design issue. So ASCE7, we all know and love it, does not have CLT in Table 12.2.1 for a response modification coefficient. So the CLT handbook, which was published a couple years ago, recommends an R equal to 2. We are doing some work to try to zero in on a slightly more accurate value for that R, but for now you can use R equal to 2. There is also an option you could use a prescriptive lateral system in conjunction with a CLT frame. So if you wanted to use, a steel frame for your lateral system and use CLT for your gravity loads, that is allowable as well. Other options you have, performance-based design per ASCE 7 or demonstrating equivalence to an existing ASCE 7 system. Or you can do a FEMA P695 and FEMA P795 analysis, which is something that we are starting, but it's going to be probably a lengthy process, and we're not 100% sure when the project will finish, but we are looking into it. There has been some additional research going on with Nice. John Vanderlint has been spearheading some of that. And the folks up at FP Innovations have also been doing some additional work with the seismic proclivity of CLT. One other test that I do want to make you all aware of is a shake table test that was conducted at eDefense over in Japan on their shake table. This was a 7-story building. The panel thickness was 5.5 inches for the first 2 floors, and then got smaller as it went up. And they subjected this building to the 1996 Kobe quake, which was a pretty substantial quake. And they cycled it, I believe, 14 times, and the building didn't fail. There was some cracking at the connections at the bottom, which is to be expected after a large seismic event like that. But overall, I think everyone who has seen this test and witnessed the test is fairly impressed with the resistance to seismic loads that CLT is displaying, and we think it's going to be a good solution for seismic resistant structures in the future. So with that, we have one more poll.
Actually, I think we have 2 more, but...
Oh, well, one more for me, anyway.
1 more for you. So, okay, let's go. Cross-laminated timber panels used in bearing wall applications require additional framing above the openings in the panel. Is that true or false? And just ignore that I missed a period there. So, all right, about 70% have voted, about 10% more, 10% more, or about 15 seconds. All right, I'm going to go ahead and close the poll. We're pretty split on this one. 78% say true, 22% say false. And
Okay.
Lori, I'm going to leave that to you.
And the answer is true. So that was something that we had discussed when used in a bearing wall application. You will need to have a separate header that will carry those loads over the opening because of the nature of how CLT is produced. They don't apply adhesive on the narrow faces of the panels. It's only on the wide face of the members. So between the layers, but not in the layers individual members. So you do need to be aware that if you've got a bearing wall in CLT that's got a header application, you will need to use something other than CLT to carry that load. So, all right. Well, good deal. So, next we're going to kick it back to Michelle, and she is going to talk about some fire.
Michelle, if you can hear me, you may be muted.
Okay, thank you everyone. Thank you, buddy. And you're right, I was muted. So before we get into the fire resistance and calculating fire resistance, I wanted to point out that the publications are freely downloaded. The standards are downloaded from our website for free. And if you noticed, I'll go back to the home page, which is awc.org. You click right here under quick links that says publications, and this provides you with a list of all the publications that are available on our website. And more specifically, we have the 2015 NDS that can be downloaded for free. This is a view-only version. We also have a purchase version where you can print it out. And then also, one thing to note is for the free-only version, it does not include the commentary, which is very important. That is available now with the commentary for purchase. And then we are actually having some hard copies printed this month to be available. I know some people like to have the book available. The other thing I wanted to point out is I mentioned the code-conforming wood design, and that is available, same page under publications. And you click on this link and you would see going back to 2009 was the updated version, and then we have the 2015 that has all the provisions related to, not all the provisions, but a provisions related to heights and areas, the revised versions related to code conforming and determining your heights and areas of their buildings. So you can download this for free, and the tables have been updated. But as I mentioned before, the end results of actually obtaining the baseline allowable square footage of a story is the same. It's just how you get there that's different. So I'll go back to here, and then we'll get into the fire resistance related to the wood products that we're discussing today. Okay, so now how is fire resistance required? There are methods within the code. I believe it's a total of 5 methods, overall methods, that are providing fire resistance to buildings as a whole, not just wood construction. And they are listed in Chapter 7 of the IBC. One method is that you can test an assembly in accordance with ASTM E119 or UL 263. I mentioned ASTM E119 previously when I showed a picture of an assembly of a cross-laminated timber with gypsum on each side. That was a ASTM E119, I'm getting a little tongue-tied, test. And then there are other methods of determining fire resistance. One is the deemed to comply tables. Those are the prescriptive tables within the code. And then also another method is calculated fire resistance under 722. Both of these methods have been in the code for quite some time. Now, the one thing I do want to point out is when we're talking about heavy timber construction, those types of construction, or that type of construction, does not require a method of providing fire resistance because there are minimal dimensions that are specified in the code that have a performance that are presumed to be adequate to resist fire. And so when I'm talking about calculated fire resistance per Chapter 16 of the NDS, that is for where you have a Type 3 or a Type 5 construction that requires a certain amount of fire resistance. So heavy timber does not need to comply with this calculated fire resistance. Hopefully that's not too confusing, and if you have any questions, you can contact us and we can provide that. But bit of a clarification, because I know sometimes it gets confusing to some people if you're in heavy timber construction, that some may require an actual calculations for the fire resistance, but it does not apply there. Okay, so related to fire and the performance of wood construction, in this particular example here shows a glue laminated versus a steel beam. Glue-laminated timber being on the left, and they both started out as the same strength. One would be, for example, a Type 2B construction where the wide flange is not protected by any sort of fire protection, and then we have the exposed glue-laminated timber. Now this actual test, you can download the actual publication that explains the test using this link. But as I mentioned, we have both members at 100%, meaning they are both the same strength, structural strength, comparative strength. And then we have wood, the glue-laminated timber represented in the wood, the brown colored, and then the steel represented here in the gray. And so strength is on the vertical axis, and then on the horizontal we have time. So going up to 30 minutes, you can see that there was some loss of strength in the glue-laminated timber, but at 30 minutes it only lost about 25% of its strength, whereas an unprotected steel member lost 90% of its strength. So this is one reason why we can, to provide a background regarding this fire resistance and determining fire resistance of exposed wood members. Now, the actual chapters or section 722 of the IBC for calculated fire resistance does reference exactly the National Design Specifications for Wood Construction, Chapter 16. And that's the chapter that we'll be talking about moving forward. So fire resistance can be provided up to 2 hours of fire resistance, and for columns, beams, tension members, it is in an allowable stress design, not LRFD. So if you're using LRFD, you'll have to back into this using the ASD provisions or method of determining the strength. But where this would be applicable is, say, what if you had a Type 5 construction, just a regular building, a business occupancy, where an architect would like to see an exposed glue-lam beam, but it's required to have 1 hour or 2 hours of fire resistance. This is where this would come into play. So they don't have to wrap the glue-lam beam in drywall. You can actually calculate a char rate to up to 2 hours of fire resistance. Now, covered in this chapter is lumber, glue-laminated timbers, structural composite lumber, decking, and then new to the 2015 NDS is cross-laminated timber. And that's a 2015 IBC references. And the methodology in the Chapter 16 is based on a mechanics-based model and supported by empirical data, the testing data. All nail-laminated timber, glue-laminated timber, and cross-laminated timber can be designed for fire resistance under this Chapter 16 methodology. And as I mentioned, these equations do provide a method of calculating the char layer that will occur, because we know when wood is exposed to fire, it will burn and it will char. So what happens is there will be some charring effect that will occur, but then to some point it will prevent the fire from burning any further. So it basically insulates that member from further burning. And we can calculate using the equations in the NDS how much char layer we'll need to provide a certain amount of fire resistance. And a rule of thumb is 1.5 inches of wood member is equal to 1 hour of fire resistance. So in essence, you're building on and building into that wood member a sacrificial layer that will burn away. And then once that layer is burned away, you check the structural capabilities of that member after it's been charred or burnt or been exposed to fire. Now, where does we find the application for nail-laminated timber? Well, nail-laminated timber is similar to timber decks, which is covered under 16.2.5, and there is an actual minimum thickness requirement of 2 inches or greater. And the key is that the planks or the nail-laminated timber, the members, need to be supported from beam to beam. In other words, you can't cantilever and have a joint mid-span or in between the spans. They have to be supported on each end. Also, when calculating the exposure of that nail-laminated timber, there is an assumption that if you imagine, there may be some gaps between, minor gaps in between the nail-laminated timbers, and we have to accommodate for that in our calculations. So the fire could wick up within those gaps, and we would have to calculate the exposure of the wood member, not just to the bottom side, the underside of that member, the 2x, but also to the sides. And there's procedures within the NDS that mentions that char rate on the sides needs to be reduced to 33% of the effective char rate. And these calculations do not address the thermal separation that could occur between the nail-laminated timber. So there, under this section, you can calculate what charring or what additional depth and width you would need to calculate up to 2 hours of fire resistance. And glue-laminated timber has been used for it's probably one of the oldest engineered wood products out there, and probably one of the most popular ones that are used in heavy timber construction. But when we're calculating the fire resistance for glue-laminated timber, there are some minimal prescriptive requirements related to the tension lambs of a glue-laminated timber. In this example, we would see an unbalanced condition, which Lori mentioned previously, the difference between unbalanced and balanced. And in this case, we would have tension lambs on the bottom. For up to 1 hour of fire resistance, you need an additional tension lamb on the bottom, and then from 1.5 to 2, you need 2 tension lambs on the bottom, because we are assuming that when exposed to fire, it's going to char that fire and burn away that fire. So we need that extra laminations in order to take care of the tension stresses on the bottom. And here's another example of what we would need for 1 hour or 2 hours of fire resistance rating. Or this one actually just shows the 1 hour. So that's prescriptively required in the NDS. And for there are equations within the NDS that shows how to calculate the char depth. But the one thing to consider also, which is key, is the protection of the connections related to when you are calculating an exposed member. In the NDS, it specifies that if there are connections that are exposed, it needs to be protected by either wood or gypsum board or coatings, and this is key, is the coatings need to be approved for the required fire resistance time or endurance time. In other words, if you're calculating for 1 hour of fire resistance, then the coating needs to be have the endurance of 1 hour of fire resistance, 2 hours, etc. So that's key to that, using connections in a fire-rated glue lam or even a sawn lumber if you're using the calculations. Here's some examples of connections that can be used for the fire resistance rated calculated method. And the key is that the steel or whatever is being used to connect the two members together needs to be protected and hidden within the wood member. Here's another example that shows two wood beams that are connected together. They use a typical standard column cap, and then this is being protected by 2x wood members. And remember the rule of thumb, if we have 1.5 inches of wood member, that is equal to 1 hour of fire resistance to protect that steel. And another one that shows we have a wood member that's coming in and connecting, wrapped around. This kind of shows it as if it's through the wood member or the wood beam, but actually this wood is actually wrapped around, or the gypsum, I'm sorry, is wrapped around the member, 5/8 drywall, type X drywall around the wood member, and then by the assembly of this behind this gypsum board, and the gypsum board preventing any fire from penetrating through protects these side plates. This actually is a hidden steel plate that connects the beam to the column. The bolts are recessed within the wood member, and then there's a wood plug that protects that steel from being exposed to fire. Here's another application where we have steel connection, and the wood beam is bearing on the, in this example, a concrete column, and a steel connection, and protected by an approved fire protective coating on these side plates. And sealing application there. I'm protecting that. These happen to be actual proprietary connections. This I don't believe is proprietary on this site, but it's a curved plate where it's a plate that's hidden up within the columns. You have bolts that are connected through, and then this would need some type of wood plug to cover the bolts of this member to prevent it from being exposed. These connections are actually proprietary connections, again, that are hidden within the wood member and covered with a wood plug to prevent exposure. These should be, if we're using the calculated fire resistance method, these should actually be recessed. So a wood plug could be installed over it or covered with gypsum or some type of protection, approved protection for that. Now, let me back up. Well, I'll go to our TR10 in a minute. But we do have better graphics for those connections in our technical report 10 that shows some more information on this. Now, related to cross-laminated timber, there is a method for calculating the char depth for cross-laminated timber, which is shown in this equation here. The one thing to be aware of is this equation assumes that all the laminations are of a equal thickness. And for example, just say you used a 2x, so all the 2x laminations throughout the depth of the member are of the same thickness, because there's a stepwise action that occurs when the cross-laminated timber is exposed, and in that stepwise calculation it assumes certain equal thicknesses throughout the depth of the member. Now, we do have an example within the commentary that shows how this can be adjusted if you have laminations of different thicknesses. And if you're dealing with European panels, sometimes they will come with laminations of different thicknesses. So something to be aware of. Only for this specific equation is only equal lamination. Similarly, this table here that gives you some actual calculated char depths depending on your requirement. If you have 1 hour of endurance, your lamination thicknesses are 1 inch, for example. You need 2 inches of char depth to meet that 1 hour resistance if your laminations are 1 inch thick. So again, this table is based on the assumption that all the laminations are of equal thickness. Now, it was mentioned that the CLT is, there is a manufacturing standard, ANSI APA PRG 320 2011, which it references, this wasn't mentioned, but it references the ANSI AITC 405-2008, which is actually for adhesives. And the one thing to note about this is these are the adhesives that are used in structural glue laminated timber. So we're using the same glues or adhesives that have been used for years in glue laminated timber that has a history of performing very well under fire exposure. Those adhesives are the same adhesives that are being specified in the manufacturing of the cross-laminated timber. And I mentioned that the PRG 32211 is the reference manufacturing standard in the 2015. There is a 2012 version that is available from APA. This is not specifically referenced, but there were no major changes from the 2011 to the 2012. It was mostly editorial changes. So this is the most recent one that's published, but the one that's referenced in the IBC 2015 is a 2011 version. The one thing to note is, though, with regard to the adhesives that are being used, both versions reference the same ANSI AITC 405-2008 for adhesives. Okay, excuse me. And now, related to other applications of cross-laminated timber, here's a little bit of, I mentioned the CLT project in Melbourne, Australia. This, I believe, is the tallest now building that I don't think it's quite complete, but it's a 14-story building in Bergen, Norway that used cross-laminated timber. This shows you that it did use cross-laminated timber in the elevator shaft as well as the stairs, utilizing it for, stairs being utilized for their exit route or egress route. So utilizing it in the entire building of being built out of cross-laminated timber. Now, the one thing I also want to point out is related to when we're talking about calculated fire resistance and using Chapter 16 of the NDS, we do calculate a char rate and a char depth, and it's a stepwise approach to calculating the fire resistance. We know that if we're looking at a cross-laminated timber, for example, say if this was a wall panel, we have cross-laminated timber and 2x member or some type of nominal member vertically, so the grain of the wood is going up and down, and then the next layer, 90 degrees to that, is the grain is in and out of the page. So you would see end grain here. And so they alternate, thus the name cross-laminated timber. So what happens is when a panel is exposed to fire, let me go back, oops, is exposed to fire on this side, we would calculate the fire resistance, and it would expose this first lamination and burn and continue to burn, and then the calculation changes as when it's a stepwise process. When it does hit the adhesives and then the actual laminations that are going in the 90 degrees to that. So we know that the charring can occur. This is just a graphic. If we have fire exposed on one side, we have the vertical laminations going up and down the slide, and we calculate the fire resistance. And when we calculate the fire resistance and then we calculate what is left of the wood panel or the cross-laminated timber, we calculate it based on as if these laminations that are in and out of the page are not there. So it conservatively calculates the section properties based on the net section. We don't include the sections in and out of the page when checking the structural strength after the panel has been exposed to the fire. So I believe we have a poll question, Marcy.
Yes, we do. All right, let me launch that. All right, just true or false. The calculated fire resistance in NDS Chapter 16 may be used to determine the fire resistance of exposed nail-laminated timber. And you know what? I'm noticing this doesn't have a period either. I think it was that there's a limit of the characters, so I think it just chopped those periods off. All right, so we've got 60% voted, 30 seconds. Let's get our votes in. Once again, we're pretty even, not evenly, but kind of divided on this answer. So these questions must be a little harder this webinar. So let's see. I'm going to give about another 5 seconds to vote, and then I'm going to close and share. So about 73% say true and 27% say false. And Michelle, I'm going to let you share what the real answer is.
Okay, the answer is true. And if you download the presentation, it's covered under slide 110 or section 16.2.5, which talks about timber decks and nail-laminated timber. And I want to show you one more thing related to this, and it has to do with our TR 10, which is our Technical Report 10, and I'll reference it further, regarding finding out more information related to calculating the fire resistance of exposed wood members. And it has some information also further on relating to calculating and charting. And it has, I mentioned the graphics. There are better graphics of the actual connections related to exposed wood members and more detailed requirements or examples of covering the connections or protecting the connections, the steel connections. So now I'll get into, let me get a, I did from current slide. Apologize for that. Let me go here from current slide. This is something that's relatively new because there was a fire test that was performed by AWC back in September this year. And what it was, it's a demonstration fire test that used some of the requirements or much of the requirements from an E119 test, but it was not an official E119 test. But it exposed two structures, one of an entire structure of cross-laminated timber, which is 5-ply, which is approximately 6 3/8 inch thick wood panel, and all 4 sides and the roof was of this 5-ply. And then the second test was similar, all the same walls, but then it used nail-laminated timber, all the same thickness, exposed to fire. The key is and then in addition to the wood member, it also had 5/8, one layer of 5/8 type X drywall on both sides to provide an assembly. So you have the 5-ply, 6 3/8 inch thick CLT or nail-laminated timber on the roof, and then 5/8 type X. And then it was loaded on the top with 40 pounds per square foot of loading on top. And it was packed entirely with furniture, the fuel that would create the fire in this example of a residence, using 95th percentile of the actual requirements for E119 for exposure to fire, providing that fuel. And as you can see, the test, and there was an extreme amount of fire that occurred because of the amount of furniture and such in the actual room. And this shows you a graph that shows heat release on the vertical axis and time on the horizontal axis. So you can see as the fire or the contents was exposed to fire went along, and then the amount of heat was very extreme, all the way above 5,000 kilowatts of heat release for being exposed, the structure being exposed to this amount of heat. And then over time, as the fuel ran out, basically, after about little less than 15 minutes, you can see the heat was decreased over time. But the other thing that's even more impressive is that when we do if we did an official E119 curve or a fire, this would be the curve that you would have to test the structure or the assembly to, this little dash line. So over time, it would have to be exposed to a certain amount of temperature over time. Now what you see here is based on the sensors is that over time we in less than 5 minutes we exceeded the temperature that was required for an E119 test quite a bit, all the way up to above 2,000 degrees Fahrenheit. And then after about 15 minutes, similar to what was shown before, is that temperature decreased because the fuel, the furniture, started to burn out, and then there was less fuel, the furniture, to provide that amount of heat. So the interesting thing is, or interesting fact is, that after, and this was exposed to quite a long time, over 3 hours of fire resistance, looking back in the room after 60 minutes after the test was halted, you can see that the exposure to the cross-laminated timber and the fire is, there's very minimal destruction or any charring of the fire of the cross-laminated timber, only in this, I think I have a close-up. No, I don't have a close-up. But there was a little bit of charring here. You could actually go in and touch the actual cross-laminated timber, and it was cool to the touch. So quite a bit of fire resistance that's provided. Now, if you're interested in seeing more, we do have a recorded webinar on our website, links on our website, that shows a webinar that was provided about the actual fire test. The report, I don't believe, is actually available quite yet. They're still writing up the report, but that will soon be available as well. If you'd like more information related to actually the different methods of calculating fire resistance, which I didn't go over all of them, just the ones in the NDS, we do have an article that's available on our website for a free download that gives you more information related to fire resistance of exposed wood members. And sorry, I just messed up. Sorry about that. And we also have, as I shown previously, a technical report 10, which gives you background information on the NDS provisions, and it also has detailed design examples on how to calculate fire resistance related to different members. So this can be downloaded from our website for free. And now, so we're something to end up the webinar with some less technical information, but something to get those creative juices flowing. We have some examples of wood being used in some pretty interesting applications. This is a pedestrian bridge in Burnaby, British Columbia. The architects are Perkins and Will, and engineers Fast and Epp. That spans quite a bit of distance. Oh, sorry about that. Really apologize. And I know I'm going to get comments in the feedback survey about this. Sorry about that. I blame it on the holidays, let's just say. Okay, so here's a pedestrian bridge that provides very aesthetically pleasing structure. I think this actually won a design award, an NCSEA design award. And it spans 145 feet over a busy intersection. And then we have, some of you may be familiar with Cathedral of Christ the Light in Oakland, California, that used heavy timber construction. This is approximately 10 stories tall. And they actually did a mock-up test of a section of the system to test it. and all exposed members. And then this is an application of using nail-laminated timber in China. You can see the prefabrication of the nail-laminated timber sections. They're pretty versatile on providing architecturally curves and roof systems. And this is a project I showed previously. It's a school in Richmond, British Columbia. Provides curving properties. I know the engineers in the audience are probably cringing at this. And this is the first mid-rise project in North America up in Quebec, 4 stories. One of the huge advantages that we just touched on barely is the actual erection process. Since a lot of this is fabricated off-site, they can quickly erect the structure. And this one, they thought it would take 7 to 8 weeks to erect, and it only took 22 days, construction days, of working 5 men, 10 hours a day. And some people were asking about projects in the U.S. This is an example of a project in the U.S. This is the first school in West Virginia, and this is prior to it being adopted in the 2015 IBC. A 46,200 square foot school. Took 8 weeks to assemble this structure, and I think it was completed this fall building it all out of cross-laminated timber. Okay, and I think that's it for the presentation, and I really apologize for the mess up with the clicking through the slides. So, Buddy?
Yes, thanks, Michelle, and Lori will bring you back too. And
all right.
If you're there, Lori, we had a question earlier about appearance grades for glue-lam. You had mentioned some of those, and one of the questions was what's the default appearance grade if nothing is specified?
So I think you probably would get something, if you didn't specify an appearance classification, you likely would get something either on the industrial or framing end of things. Architectural and the premium appearance grades are likely going to be produced of higher quality lumber, which is probably going to have a higher cost associated with it. So if you're just specifying that you need, a 22F beam, I would imagine the supplier would give you, an industrial or a framing application, because that's probably what they have in stock.
Okay, great. Let me remind folks that we've got about 10 minutes left till the top of the hour, and so to get your 2 hours certificate, make sure you hang around, and we'll take questions now. So if you have some questions, feel free to type those into the chat box. Michelle, we got a question earlier. Oh, go ahead.
I was going to tag on to Lori's answer, and she did mention this, but for those that didn't hear, the appearance grade does not affect the structural properties of the actual glue-laminated timber.
Correct. Thanks for that clarification. Michelle, this question's for you about CLT and elevator shafts. So one of the questions was whether or not if you use CLT in elevator shaft, whether that needs to be protected with some sort of gypsum or something like that.
Okay, and this is a very good question. There's really nothing in the code that we require CLT specifically to be covered. However, one needs to think about when you're dealing with the elevator shafts that there are fire resistance requirements, and does that comply with the rated assemblies? looking at the fire resistance side of things. So not specific to that material, but there may be requirements to provide that gypsum. Also, then assuming that it's in a concealed space, there may be some conditions that require sprinkler protection for exposed combustible materials in a concealed space.
Right, right. Did you mention the interior finish requirements too, like
No, I didn't.
a flame spread? So there may be, if it's an occupied space, there might also be some other finish requirements as well.
Right. Good call.
Okay, good questions. Lori, I'm going to throw this one back to you with regard to the headers in CLT, and you may have addressed it, but I know we got some more questions about it. What are the options for dealing with headers in a load-bearing wall application? What's really the only option at this point?
I think there are some folks that are taking a CLT panel and kind of using that on its side. I've seen in some applications. I'm not sure if that was in a European application, but I think you probably could use an LVL or other engineered wood product also.
Yep, the key in what we've got in the NDS commentary is that it really does go back to the manufacturer at this point. Yeah. We're continuing to research it, but at this point need to touch base with the manufacturer, see what details they recommend for that. I saw one response where manufacturers were suggesting you could turn the CLT 90 degrees, and
right.
So that's another option as well. Michelle, let me ask you if you could maybe, since I think you've got the controls there to navigate folks to the Technical Report 10 document. There were some folks that were having a tough time finding that, and you mentioned the connection details as well. Maybe you could show those while we look at a few more questions that are coming in here. So yeah, if you're following along, Michelle went to the publications page, and then under technical reports, technical report 10. From the main page, it looks like there's also a link there for publications and technical report 10. If you could, go ahead and pull up tech report 10 and the free version, and let's scroll down to the to those connection details that you mentioned earlier. All right. And Michelle, if you are, you might be muted. I don't know if you're chiming in or not, but.
Okay, it starts on page 33 of the document, 39 of the PDF. Can you hear me?
Yes, I can now.
Okay. Okay, and so here's the guidelines for wood members and the connections. That provide you. Is that what you wanted to show?
Yep, that's perfect.
And here's also, for those interested, I mentioned design examples. This is a design example of an exposed beam.
And I think there's a CLT example in there as well. And so this is the technical report 10 has been updated to include CLT, and so there is actually a CLT example problem there as well. So that's a good resource for folks to download.
Yeah, example 4.5, exposed CLT floor application.
All right.
The other thing, back to, I know we didn't touch on this, but back to the publications is the TR12, but you may have wanted, which deals with connections, dowel connections, expanding beyond what's in the NDS.
Yep,
So.
yep, very good. Okay, and I think one of you may have mentioned this, but again, it's coming in with the questions. What U.S. manufacturers for CLT are there at the moment?
As far as I know, there is one out in Oregon. I believe there is another in the eastern half of Canada as far as North American manufacturers.
And the one in Oregon is, as far as I know, is the only one at this point that was certified by APA.
That's right.
Per the PRG 320 standard.
Here, I don't know if you're watching this, I brought up this Rethink Wood website, and it has a tall wood mass timber tab that shows a list of mass timber manufacturers in the U.S. showing here.
Great. Great. Michelle, maybe clarify too the current version of the PRG standard. I know that was mentioned, the code and the NDS reference, a certain version.
And here it is.
Okay.
If you go to the apa.org website /ANSI-APA-PRG-320, or just do a Google search doing that. Here it states the PRG 320-211 is the one that's adopted in the 2015, and then the 2012 is a more current version. But as I mentioned, there's only editorial changes between the 2000 and the 2012, and you can download this from the APA website.
Great.
Although you have to have a username and password to download it.
Okay, yeah.
Anything else? I think we're almost up to the top of the hour.
Yeah, we are. And I'm looking here just to see if there are any other questions here. I'll
go on.
Just to clarify again for their questions about shear walls and seismic R factors for shear walls, you did mention the CLT, the US CLT handbook has some information, but again, that is ultimately going to be up to the designer, and the code official would need to approve those seismic R factors. We're still right in the midst of research on those products, and it is a very long process to get R factors developed for shear walls. And so designers and code officials need to discuss that to make sure they're on the same page with any CLT panels used in seismic shear applications. So, Lori, go ahead.
There was a question regarding appearance classifications, and that is covered in the PRG 320. You can see, I don't know if you're seeing my screen, section 7.3 that covers appearance classifications.
Great. Well, Lori, Michelle, thank you for an excellent presentation. I want to ask Marcy if she would to come back and close us out since we're at the top of the hour. And thank you folks for joining us, and we'll hopefully see you again next year.